So this new video is on the limiting sum. So here's a little bit of a joke to start the lesson. Alright. So the heading is limiting sum, and this is the new formula. The sum of infinity is a on 1 minus r. And a series will have a limiting sum if the common ratio, the absolute value of the common ratio, is less than 1. So that's the condition for a limiting sum to exist. So you can see in these two different examples here of two different series, we've got this series here where the first term is 2 and the common ratio you can see is 2. And you can see this series is just going to get bigger and bigger and bigger. And so that sum is just going to get bigger and bigger and bigger. So you can say this series diverges. Whereas this series here, the first term a is 2, but the common ratio now is half. So the next term's going to be, an eighth and a 16th and a 1 on 32, etc. So each term is getting smaller and smaller and approaching 0. So you can see that this series converges, and then the sum is going to approach a limit. So here's the proof of where this formula comes from. So there's the formula that you know for the sum of n terms in a geometric series. Now, as n increases, this term here, r to the n, is going to decrease and approach 0. So, for example, when r equals a half, you will get half to the power of 10 is, say, 1 on 1024, or half to the power of 20, you see, is 1 on 1,000,000, 48,576. So that denominator is getting bigger and bigger and bigger, which means the whole fraction is getting smaller or approaching 0. So this only happens when the common ratio is less than 1, or the absolute value of the common ratio is less than 1. So when you've got a fraction like that. So that means then in our formula, r to the n part is approaching 0, and 1 minus 0 is just 1 times a, and then that's why you just get that beginning part. So that part there is the limiting sum formula, because r to the n is approaching 0. When r is, the absolute value of r is less than 1. Alright, so let's have a look at some. What is the limiting sum of this series here? So the common ratio is, that the first term is 10. The common ratio is 5 on 10, or 2.5 on 5, which is half. And so the limiting sum, which we use the notation sum of infinity, is a on 1 minus r. So 10 divided by half is 20. And then in number 2, very similar. The first term is 60. The common ratio is negative 30 on 60, or 15 on negative 30, which is negative a half. And so the sum of infinity, sorry, that's not my phone, that's someone else's, can't turn it off, is going to be 60 on 1 minus r. So 60 divided by 3 on 2 is 40. Alright, then you'll have questions which are application questions, where you've got to identify that it's going to be a limiting sum. So we have a 3 metre high tree. I might have to pause this for now. I'm back. Alright, so we've got a 3 metre high tree, and then it grows to 1 metre taller 1 year. So we've got the 3 metre high tree, and then in the next year it grows another metre, and then in the next year it grows 1/3 taller. So it grows 1/3 of a metre, and so on. Each year growing 1/3 taller by 1/3 of the last year's height. Find the tree's ultimate height. So we need to find the sum of all of these terms, and you can see that it's going to be that the first term is actually going to be well, starting here, we've got, let me just write the numbers in a series. So we've got 3, and then we got 1, then we got 1/3, and we got 1/3. Oops, that's supposed to be a plus. 1/3 of 1/3. Oops. 1/3 of 1/3 is 1/9, etc. So we can do this two ways. We can either say the first term is 3 and the common ratio you can see is 1/3 or 1/3 divided by 1. Either way it's both a third. And so the ultimate height will be the sum of all of these, which is A on 1 minus R, which is 3 divided by 2/3, which is 3 divided by, 2/3, which is 9 on 2, which is 4.5 metres. So that's one way of doing it. Another way of doing it is you could say that it is equal to 3 plus, then using this as your sum of infinity. So then that would be 3 plus, using this bit is the sum. The first term is A, which is 1, on 1 minus R. You can see there the rate is still 1. The common ratio is still 1/3. So we've got 1 divided by 2/3, which is 3 on 2. So 3 plus 3 on 2. 3 on 2 is 1.5 plus 3, and still get the same answer of 4.5 metres. Okay, Johnny bounces a ball, dropping it from 1.5 metres on its first bounce. So it's going to go down 1.5 metres. It then rises up to 2/5 of its height. Be about that much. Oh, I'm going to draw it at an angle, but really the ball is going up and down. The ball's going up, down, but all these little lines are going to be on top of each other. So, like this. So, I'm just going to draw them going sideways a little bit just so you can see what's happening. Okay, find the distance through which the ball travels. Alright, so where is our series? We've got 1.5 is the distance it travels. And then see what happens here is that distance and that distance is the same. This distance and this distance is the same. This distance and this distance is the same. Really, remember though, it's going up and down, up and down, up and down. So we've got 2 lots of this series here. So we've got 1.5 plus 2 lots of our series. And our series, the first term there is what? Let's say, what is that first term? Well, it's going to be 2/5 of 1.5. And what is 2/5 of 1.5? I think it might be 0.6. Let's check. Yes, it is. And our common ratio, well, you can see that that's going to be 2/5. It's going 2/5 of the previous amount. Alright, so that's kind of a bad way of writing it out. Well, we've got 1.5 is that first distance plus 2 lots of, and then we've got this infinite sum of infinity, a converging sum. So it is going to be A, which is 0.6 on 1 minus R. And then you'll get that the ball travels a distance of 3.5 metres. So I guess what you've got to think about in some of these word problems is, where is the distance doubled? Yeah, which distances are may not included in the series. So the 1.5 wasn't in the original series there. Or you could have had one series starting at 1.5 and another series starting at the 0.6 and then adding those 2 series together. There's always multiple ways of answering a question. Let's have a look at what is the condition for this series to have a limiting sum. So remember right at the very beginning, the common ratio, the absolute value of the common ratio had to be less than 1. So let's see, what is the common ratio for this series? Well, T2 divided by T1 is x, so that means the common ratio must be x. And the common ratio's got, the absolute value of the common ratio has got to be less than 1, therefore x, the absolute value of x has got to be less than 1. That's the condition for that series to have a limiting sum. And one last example, we've got a decimal here, recurring decimals. You probably remember doing those, changing recurring decimals to fractions back at the beginning of year 11. And I said there was another way of doing this, and this is the way. The decimal 0.34 repeater can be considered as the sum of a geometric series. So what that means is 0.34 repeater can be considered as 34 over 100 plus 34 over, add another 2 zeros, plus 34 over, add another 2 zeros, plus, keep going. Alright, because then you get the 0.34, 0.34, 0.34, 0.34, etc. And then you can see in this series, the first term is 34 over 100. The common ratio is going to be 34 over 10,000 divided by 34 over 100. T2 divided by T1. And you can see when you multiply it by the reciprocal there, the 34s are going to cancel. 100 divided by 10,000 ends up being 1 over 100. So there's our common ratio there. So that's the answer for A. And then part B, hence or otherwise express 0.34 repeater as a fraction. So because you can see that the common ratio, 1 over 100, is less than 1, that means it's going to be, this sum is going to converge. So it'll have, you can find the sum, the limiting sum, and then that sum of infinity is going to actually equal what another way of writing 0.34 repeater is. So I'll get rid of the equals and I'll just write 0.34 repeater is equal to A, which is 34 on 100, over 1 minus R. Okay, and then that ends up being 34 over 99, which is what you would have got the other way, doing the 2-unit method. That's it.